Okay, hello everyone. This is the additional video for some exercise and practice. Okay. Uh, Later on, you can also look up to the Google Classroom for some exercise or practice. Okay, let's start from this question first. Okay, this is about the fundamental theorem of calculus. Okay, let's see this question here, and I would like you to also try by yourself. Stop the video, check the equations first, check the questions, try to solve, and then we can compare later. Okay, now first thing, let's write the functions. So we have functions of integrations from 2 to x of e with power of t squared and dt. Okay, the question is asking equation of the tangent line. Remember, if you have the tangent line, this means that you need to have, so we need to find the slope. Okay? The slope is our first derivative, right? Or let me write as dy over dx. Okay, or f prime, or in this case, our function is the big F, that we need to find the first derivative, in which we have e x squared, like that. And we need to find the slope at the point x equal 2. So at x equal 2, the slope is e4. Okay. Okay, at x equal 2, then our functions become this. And remember, when we have these integrations, the same endpoint like that, we will conclude that this will be 0. Okay? So when x is 2, y is 0. So we can have our line equations. Let me write the line equations. Y minus 0 equal, the slope is e with the power of 4. Okay? And then the x minus 2, like that. And we can have this equations, okay, as our tangent line equations. Okay, I hope you guys got the correct answer. Okay, next one. This is the question. Find the function of f and a number a. Okay, so stop the video and try to solve by yourself. Okay, let me start. Let me write this whole thing, 6 plus. Okay, equal to. Okay, now the idea is how to remove this integral. How to remove? We need to differentiate, right? So we can differentiate this ddx and this ddx, like that. Okay. And we get the left part become f of x and x squared equal, the right hand will be 1 over square root of x, because if you have this will be the case, right? So you will have 1 over square root of x. Okay, and then try to solve this, we got f of x is x squared divided by square root of x, or this f of x is equal x with 3/2 power, right? Okay, how to find the a? So to find a, so to find or to determine a, let x equal a. Okay, now we put into our equation okay, and now the whole thing at this integrations becomes 0, right? So this is 6 equal to square root of a, and a, or 2 square root of a, or square root of a is 3, or a is 9. Okay, so that is so the functions is x with the power of 3/2, and a is 9. Okay, I hope you get the correct results. Okay. Okay, next question. Okay, we have two pictures, A and B. Okay, the area is labeled A and B. So area B is 3 times area A. So the questions is asking what is B. So express B in terms of A. So we need to, so the expectations is we need to write B blah 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 A something something. Okay. So we need to find B. Okay. Okay. So first, if A and B is area, then A or or B, as mentioned in the questions, is 3 times A. Okay, you can try to develop this. Okay, and now, okay, because B and A is an area, okay, to find the area here, okay, this curve here, the area under the curve will be integration from 0 to A of our function is e to the x dx is A. Okay, and the same way with B, with integration from 0 to B of our ex dx is B. Okay, now if we are start from this B, let me write here, this is actually 3A, right? 3, and then we can write this in terms of the x like that. And we can integrate, because e to the x is, I think it's easy to be integrated. Then we can write that, and 3 so we can have e power of e with power of b minus e with power of 0, it's 1, and then 3, this is e a minus 1. Okay, so we have e with power of b, 3e a is minus 2, or we can write that the b is ln of 3e a minus 2. That is the answer. Okay, I hope you get also correct this one. Okay, now next questions. Okay, next questions. Find this limit. Okay, it's a limit question, but it's related to integral. Okay, I need to add some additional information I forgot to mention here. So evaluate the limit if the function defined on 0, 1. Okay. So the interval is from 0, 1. So, okay, the first thing what you need to do is remember that what is limit in integral means. Okay, remember that we have we call the Riemann sum. Okay, that is the definition of integral in limit. So limit, if you remember that we have this definition, right? So we need to define this delta and this f, and we need to find what kind of functions that we have inside. Okay. So first, usually the delta x is defined by b minus a divided by n, and we have our a and b is from 0 to 1, so we can conclude that our delta will be 1 over n. Okay, 1 over n. So first, we need to develop that 1 over n from this equation. So we can have, let me write, this will be I power 4 and 4. Let me factorize 1 over n from here. And this 1 over n like that. Okay. If we look here, okay, if you look here, now let me make it clean. Okay. This one here is, we can write I over n with the power of 4, right? This is plus I over n, like that. Okay. Now we need to find what kind of functions that we might have. Okay, so this part is our dx or our delta x, right? This 1 over n, and this part is our f of x. Okay, what kind of functions that we will have? Okay, if you think carefully, that this is fit into integrations from 0 to 1, this becomes x power 4 plus x, and then dx. Okay, please review your notes at the early introductions, or maybe on the definite integral. That is, we can have a limit definitions with this sum. We call this is a Riemann sum definition. Okay. Now, when we have this, then this will be an easier approach for us to calculate, right? Now we can get this is 7 over 10. Okay. I hope you guys get correct also. Let me check other exercise as well. Okay, let me give you another one with this Riemann sum definition. Okay, let me give you a limit as n approach infinity, 1 over n. Okay, let me give you this. Okay. And let's say we are going to evaluate between 0 and 1. Okay. First thing we do is finding the delta x, of course. So this will be 1 over n. Okay. So this is x0 is 0, n is 1, or a is 0, b is 1. So we will have, if you want to check that each one of the samples, that is, this is 0 plus 1, or I over n. Okay, I hope that that's clear. So if we look at our functions, that is from 1 over n plus 2 over n with power of 9, and until n over n, okay, this is actually defined as if you look the pattern, okay, this is actually I over n and then with the power of 9, right? Oh, I forgot the sum. Sorry. Should be having sum from 1 to n. Okay. All right, this is I over n with the power of 9, which is, we can write down that this xi, this is x with power of 9. So we can write the whole thing here. Let me just copy that for you guys. Okay, so this limit is actually equal limit as n approaching infinity of the Riemann, that is I over 9. Okay. Oh, wait. This is already correct. Sorry. I missed out. So this is already correct. Okay. This is already correct. Okay. Okay. Now this will be this Riemann. Okay. Yeah, because it's just an addition, and we can take this addition into a sum for. Okay. So we change this into sum formula. Okay. And this is what we have. Okay. And then this is 1 over n. If I forgot 1 over n here. And this will be the dx, or the delta x. This will be the fxi. Okay. Now this will be equal 0, 1, x9 dx. The same as these integrations. Okay. We can find the integrations. That is 1 over 10. Okay. Now this is the results. Okay, what else do we have? I can give you more example. Let me check. give you another one, maybe another two for indefinite integral or u substitutions. So evaluate this integral y squared. Okay. Start from a little bit easy one. Okay, now by looking at this 4 minus y cubed and y squared, we know that y cubed we can differentiate become 3y squared, and that is our clue. Okay, our key important key solutions. Okay, so we can let the u is 4 minus y cubed, then du will be minus 3y squared dy. So we can write down our integral becomes okay. Now we can cancel this, and we will have minus 1 over 3 u du, and this will be having 5 over 3 over 5, right? So we will have cancelled 1 over 5. U is 4. I think this is just okay. If we write like this, m plus c. Okay. Okay, what else do we have? Okay, let's try the other one. This is sine x sine cos x dx. Okay, try first and we can compare later. Okay, try first, pause the video or stop the video, try by yourself. Okay, now this is, I think, pretty simple. We have sine and cosine, right? And because these two functions is connected in derivatives, right? We can have our u is our cos x, and du will become negative sine x dx, and we can have the sine x cancelled with negative sine x, right? Like that. So we can cancel this out, and this will be resulted with sine u du. Okay, so we'll have negative sine u du, and this will be result in integral of sine is negative, so it will be cos u or cos x plus c. Okay, I think I can go on one more. Integral secant squared theta tangent q theta d theta. Okay, try first and let me know your results right there, whether it's correct or no. Okay, now here's the idea. So secant squared, and this is tangent cube, right? what's the connection between tangent and secant? We know that the tangent, if you derive, this will be a secant squared. So we can do that. So let's take u as a tangent theta, and we can have du secant squared. Okay, then we can write the integrations, secant squared theta divided by secant squared theta, and then u cubed du. And we got easily 1/4 tangent theta, or tangent with power of 4, okay, plus c. Okay, this is, I think, a good way to let you know or familiarize or get used to the u substitutions. Okay, I will give you more practice later. So that's it for this additional video. Hopefully we can see each other in the class.